Alright, so this video is going to be a quick review about two methods on how to solve quadratics. I'm not going to go super in depth on both of the methods, just enough though. So this first one we're going to be doing is the quadratic formula. So the good thing about the quadratic formula is this is something that you can always use. You can't always factor every single quadratic. You can't always, well, I mean, to some extent you can figure out ways to do certain things, but not everything is factorable. The quadratic formula always works. In a second, we're going to go over the method of factoring, but right now, quadratic formula. And the quadratic formula is, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and that is the quadratic formula, and you're going to get two answers. So remember that when you're actually you're solving a quadratic, potentially, and well, actually always, it has two solutions. Let's see here. How do I explain that? So you could have three options happen here. You could have, if this is your graph, if your graph maybe looks like that, and it never actually touches the x-axis, then you have two imaginary solutions. If it actually swings down and hits the x-axis in one spot, you have a solution called a double root. So it's kind of a way of saying that it has one solution. If it crosses in two different spots like that, then you have two real solutions. Okay? So here we go with the quadratic formula. Applying it to this quadratic, if I'm going to solve it, then realize I need to set it equal to 0. Once it's set equal to 0, and it's in standard form, my a is the coefficient of any squared term. My b is the coefficient of any just first degree term there. And then c is the number that's by itself over here. So I've got negative b. So b is already negative 5. So actually, let me go ahead and write it out like this. Negative b is negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 2 times a like that. And that's what x is going to equal. So that all equals x. And really your entire objective from this point on is just to simplify. So I have negative 5, so that's 5. Plus or minus the square root of negative 5 squared is 25. Minus 4 times 1 times negative 14. So 4 times negative 14, that's 40, 56. So it's going to be 4 times, so this is all going to be negative 4 times negative 14 is plus 56. All over 2. So that equals x. I'm going to go ahead and keep writing on the other side, keep simplifying. So 5 plus or minus the square root of 25 plus 56, that should be 81 over 2. And one last one right here. X equals 5. So, well, hold on. Let me pause here. So this 81 that you see right here, the square root of 81, that's going to tell you, it's called the discriminant. That number that's under the square root sign is the discriminant. And one thing that you want to remember is if this number is negative, so for example, if you're taking the square root of like negative 5, it ends up being negative 5, that's going to give you two imaginary or complex roots. All right, if it's a square root of something positive, square root of, let's say this, in this case, let's say just 8. Square root of something positive, that's two real solutions. So if it's square root of negative, there's two imaginary. If it's square root of positive, it's two real. If that square root, so some small bullets here, if the square root is a perfect square, so if the square root is a perfect square, for example, like, say it's like the square root of 4. Square root of 4 is 2. It's a perfect square. Then your solutions are going to be rational. And if it's not a perfect square, like maybe the square root of, well, in this case, like square root of 8. We don't know what the square root of 8 is as far as a solid number, and that's what we call irrational. So remember, you can figure out the types of solutions that you're going to have based on what you're taking the square root of. So in this case, we're taking the square root of 81. It's a perfect square. So you're going to have two real, rational, because it's a perfect square root, solutions. So let's keep going with this now. So square root of 81 plus or minus square root of 81 is 9 over 2. So my two answers are going to be x equals 5 plus 9, which is 14 divided by 2. So x equals 7. Or x equals 5 minus 9. That's negative 4 divided by 2, which is negative 2. So x equals 7 or x equals negative 2. I'm going to go ahead and do it one more time. I'll come down here and do it on number 8. So I need to set it equal to 0. So right now it's not set equal to 0. So I'm going to add 10 to each side. So I have 2m squared minus 7m minus 3 equals 0. All right, and without explaining too much here, I'm just going to go straight through the process so it doesn't look so complicated. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So 2 is a, 2 is a, negative 7 is b, negative 3 is c. So negative b, which is positive 7, plus or minus the square root of b squared, that's negative 7 times negative 7, so that's 49. Keep in mind, b squared is never going to be negative. So b squared minus 4 times a, which is 2, times c, which is negative 3. All of it over 2 times a. 2 times a is going to be 4. 2 times 2 is 4. Okay. So let's keep simplifying this. So 7 plus or minus the square root of 49 minus, let's go ahead and write it out. Why not? 49 minus 4 times 2 is 8 times negative 3. So that's negative 24. So minus a negative 24. So that's plus 24 over 4. So keep in mind, if I have a negative times a negative, like two negatives, they're going to cancel each other out and make it positive. So that's how I knew that was going to be a plus 24. So 4 times 2 times 3 is 24. Two negatives, it's going to be a positive. All right. So let's go down another step. X equals 7 plus or minus the square root of 49 plus 24, that's 60, 73. Over 4. Sometimes you can actually simplify this square root, but in this case, I'm trying to think real quick. I think 73 for some reason. I'm getting the feeling that it's a prime number. Hopefully it is. I'm not certain about that. If it is not, then the way you actually break it down is you say, okay, 73, maybe that's divisible by 2. Nope, it's not divisible by 2. It's odd. Maybe it's divisible by 3. And how many times does 3 go into 73? And you keep breaking it down and you get its prime factorization. So hopefully that reminds you of the technique I've shown you on simplifying square roots. But anyway, I think that is as simplified as this is going to get because that is simplified already, that square root of 73. So sometimes your answers with a quadratic formula look ugly, but x equals 7 plus the square root of 73 divided by 4, or 7 minus the square root of 73 divided by 4. And if that confuses you, look, x equals 7 plus or minus the square root of 73 over 4. That's all I did. I just wrote them both out, a positive and a negative. Okay, so that's the quadratic formula. Now, real quick with factoring, the idea behind solving a quadratic using factoring is pretty much if you set it equal to 0, there's only two ways you can multiply two numbers. And as you can see, one of the numbers is called k plus 1. So there's only two ways you can multiply this right here with this and have it equal 0. Either k plus 1 has to equal 0 or k minus 5 has to equal 0. So the idea is, again, there's two solutions. Either k minus 5 can equal 0 or k plus 1 can equal 0. And either way, if one of those equals 0, For example, if k minus 5 equals 0, then 0 times whatever this is going to equal 0, and that's going to come out to the solution. That's the idea behind factoring. So if k minus 5 is going to equal 0, then k would have to equal 5, because 5 minus 5 equals 0. And 0 times, and if k equaled 5, keep this in mind, that's going to be 0. That's going to be 6, because 5 plus 1 is 6. But 0 times 6 is still 0, so that works out. That's one of the solutions. And k could equal -1, because if k equal -1, -1 plus 1 is 0. Even though that -1 minus 5 is going to be -6, 0 times -6 is still 0, so that works out. So those are my two solutions. So again, let's apply that idea right here. If both these things are going to be multiplied together and equal 0, that means a plus 1 could equal 0, or a plus 2 could equal 0. So let's start off with this idea. If a plus 1 equals 0, let me show you it this way. If a plus 1 equals 0, let's just say if a plus 1 equals 0, then a would have to equal -1. So let's try this out, and I'll prove to you how it works. I'll just put a check mark next to it because it does work. So let's plug in a equals -1. If a equaled -1, then I'd have -1 plus 1. So that's 0 times -1 plus 2, which is 1. So I have 0 times 1. -1 plus 1 is 0. -1 plus 2 is 1. 0 times 1 equals 0. So yes, it does work. So that was if a plus 1 equals 0. That's if this equals 0. Now, if a plus 2 equals 0, if this equals 0, then a could equal -2. And the same thing is true. If a equals -2, that works out also. Those are my two solutions. Let me do it one more time. If that equals 0, then that would be a solution. So I would do 2m equals -3, m equals -3 over 2. That's one of my solutions. Or that could possibly equal 0. So let me do the other one now. 4m plus 3 could possibly equal 0. So 4m equals -3, m equals -3 over 4. So those are my two solutions. All right, so now factoring. See, this was just the idea behind factoring. I was communicating the idea behind factoring. Notice it's already factored for you. Now, if you're going to factor, the idea is you need to first set it equal to 0. Make sure it's set equal to 0. So first, set equal to 0. Next, if a equals 1, like you see in this case, so let's first set it equal to 0. N squared plus 7n plus 10 equals 0. Now, if a equals 1, once you've set it equal to 0, and in this case it does, the number before the squared term is 1. The coefficient of the squared term is 1. If a equals 1, then you're simply looking for two numbers that multiply to be positive 10 and add to be positive 7. It always works in that case. So two numbers that multiply to be C but add to be B. So in this case, it could be 1 times 10 can multiply to be 10, or 2 times 5 can multiply to be 10. And those are the only options that I have that would multiply to be 10. Now the question is, which ones add to be 7? 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. So n plus 2, n plus 5. And you can see here, now we're back to where we were up above, where we just set each one of these factors equal to 0 to actually solve. So if I set n plus 2 equals 0, then n equals -2. There's one solution. If we set n plus 5 equals 0, then n equals -5. That's the other solution. So let me go ahead and factor one more of these. Let's do number 10. So number 10, again, set it equal to 0. 7r squared minus 14r plus 7 equals 0. Now the question is, does a equal 1? No, not in this case. It equals 7. So the next thing you want to do is go ahead and check. See if every single term in here is divisible by that a. If it is, then divide the a out. So notice every single term is divisible by that 7, the a value. So I'm going to divide that out, 7. So we have r squared minus 2r plus 1 equals 0. So I just divided it out like that. Now what is left over is another trinomial, just like the one we did before. So real quick, I'm going to scroll back up.
Teachers, please don't forget, there's an EOC training this morning at 8 o'clock in the auditorium. EOC training, 8 o'clock in the auditorium. Thank you.
Well, okay, there's an EOC training at 8 o'clock in the auditorium. But, so scroll back up. Look over here. What we just did was we factored something where a equaled 1. So we needed two numbers that multiplied to be 10 and added to be 7. So it's the same thing here. A equals 1. The number in front of the squared term is 1. So we need two numbers that multiply to be 1, but add to be negative 2. That's going to be negative 1 times negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So factoring, we have 7 times, let me go ahead and write it in pencil, r minus 1 times r minus 1 equals 0. So there's my two factors. Again, if I take each one of these factors and set it equal to 0, so if r minus 1 is going to equal 0, then r has to equal 1. And that's my solution. If I do the same thing here, I'm going to get the same solution. So r equals 1 in both cases. That's called a double root. What that's going to look like is when you graph it, it's going to come down and it's going to hit your x-axis, or in this case, your r-axis, at r equals 1, right there. It's called a double root. Only hits in that one spot. Maybe I will do, let's go ahead and do one more. Let's see if there's any difficult ones on here. Well, this one doesn't look too fun. Number 20. I'm going to do this one pretty quick. So again, trinomials, set it equal to 0. Might take me a second to figure this one out. All right, so yeah, this is going to take me a second. That's not fun at all. I probably need a calculator. Let me do one that I don't need a calculator on. I think this one should be fine. I'm actually going to do this one. Same concept as the one before, except the one before I definitely needed a calculator on. I could see that before I started it. So this one's going to be plus 4a minus 3 equals 0. So again, you set it equal to 0. If you can, factor out. So look at the terms here, because a is bigger than 1. So if the terms are all divisible by that a value, factor it out. In this case, it's not. So you can actually begin by multiplying the a and the c term. So negative 15 times negative 3 is positive 45. So what I'm actually trying to do now is look for two numbers that multiply to be 45 but add to be 4. So all the numbers that could be multiplied to be 45. 1 times 45, 2, nope. 3 times 15, 4, no. 5 times 9, 6 doesn't go into it, 7 doesn't go into it, 8 doesn't go into it, 9 goes into it 5 times. So now I'm duplicating factors. Here's the factor that's going to add up to be 4. So let's see here. Negative 15, negative 3, positive 45. This is an interesting one for sure. The reason it's interesting is I'm looking for two numbers that multiply to be 45 but somehow add to be 4. Oh, man, I messed that up. That was supposed to be positive. I don't know where that became negative. So here it is. So that should be positive 15a squared. So that actually ends up being a negative 45. Okay, so it would be a positive 9 times negative 5. So we have a plus 9, positive 9, a minus 5. Okay, so positive 9 times negative 5 is negative 45. Positive 9 minus 5 is positive 4. Okay, so now if you multiplied by 15 at the beginning, then you should divide by 15 at the end. Yeah, this is a really ugly one. Then simplify these fractions. So you have a plus 3 over 5 times a minus 1 over 3. And if that's as far as you can simplify them, then you go ahead and swing up the denominator in front of the a. So you have 5a plus 3 times 3a minus 1. And that's about as rough as you get for a trinomial. But anyway, that's the answer. So if you're going to actually solve this fully out and get the solutions, take 5a plus 3 and set it equal to 0. Solve that, you'll get what a equals. And then next, take 3a minus 1, set it equal to 0. Solve that, and you get out the second answer for a.